which let me post that on Twitter. Well, how do we? That is posted. Let's start with today's thing. So advent of code. Actually, I am not. Okay, I'm not logged in. Let me log in here. I'll do it with GitHub. Well, yeah, let's do it with GitHub. And that is logged in. So let's go into day one. We will be solving this in Golang. So I'll not start with that. Let's first look at the problem. So let's read it together. So the chief historian is always present for the big Christmas play launch, but nobody has seen him for months. Last anyone heard he was visiting locations that are historically significant to the North Pole. Okay, a group of senior historians have asked you to accompany them as they check the places they think he was most likely to visit. As each location is checked, they will mark it on their list with a star. The figure a chief historian must be in one of the 50 places they look. So in order to have safe Christmas, you need to help them get 50 stars on their list before Santa takes off to the December 25th. This is the first puzzle, so that introduction will be quite long because we collect each star for uh, like part one, and part two will have second star. So in total there are 25 days, so we'll have 50 stars. So that is the introduction. So let's get on the first program actually. You you haven't even left yet, and the group Elvis senior historians have already hit a problem. The list of locations to check is currently empty. Eventually, someone decides that the best place to check first would be the chief historian's office. Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists in historically significant locations. This seems to be the planning the chief historian was doing before he left. Perhaps these notes could be used to determine which locations to search. Throughout the chief's office, the historically significant locations are listed not by name, by unique numbers called the location ID. To make sure they don't miss anything, the historians split into two groups, each searching the office and trying to create their own complete list of location IDs. Okay, so we have two lists as you can see here. They are just one problem. By holding two lists up side by side, your puzzle input, it quickly becomes clear that the lists aren't very similar. Maybe you can help the students reconcile their list. Maybe the lists are only off by a small amount to find out pair of the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list, then the second smallest number with the second smallest right number. Okay, and so on. Within each pair, figure out how apart the two numbers are. So you will need to add up all those number distances. Okay, so we have to sort uh, two indices and take out the differences. For example, if you pair up 3 from the left list, which is 7, from the right, the distance apart is 4. If you pair up a 9 with 3, the distance apart is 6. Okay. In the example list above, the pair distance will be as follows. The smallest number in the left list is 1. Yeah, it is 1. And the smallest number in the right list is 3. In the right list, it is, yeah, it is 3. So distance between them is 2. Okay. The second smallest number, okay, so we basically sort them, right? 1 and 2 here. But here, there are three threes. So it will still be 3, right? The second number in the right list is another 3. Okay. The distance between them is 1. Okay, yeah. Third smallest number in the list is 3, and here it is also 3, so this is 0. Okay. So, okay, 2, 1, 0, 1, 2, 5. Okay, we add them. The total distance is 11. Between this, add up distance between all the pairs you found. In the example above, this is 2 plus 1 plus 0. A total distance of 11. Okay, got it. So, we basically have to sort it. Like, can we do it without sorting, or we should do it with sorting because we have to create list of all the numbers and not just the smallest and the largest. So I think we'll go with the smallest. So let's first set up this thing. I've been running it for the past 3 years. Let's create for 2024 as well. So 2024. So I usually like to create source and an input file. Okay, and in the source, let's let's first go into inputs. Let's create day 01 when day 01 and sample.txt. So that is created as the day 01. So MD is just alias for me. It is mkdir and cd. So let me go in here main.go. So let me first disable this. So the first thing we need to do is obviously load the inputs. So I usually create a generic function to load this. So what I usually do is create a function called read file and take in the path as a string and return a list of strings which is separated by lines. But I don't want to do it that way right now. I'll do it with a list slices of bytes. So then if we have to do it not line by line, then we can do it customizably. So it will just return the list of bytes, and here we'll do bytes and error. Uh, So if error, so os.read file takes in a single argument, which is the path to the file, and it returns a slice of bytes and or an error. So if there is an error in reading the file, we uh, populate the error and not the file byte. So we have to check over here that there was some error in it. If there is an error, we usually log it out and return the file bytes. So this is the broader level function. So I'll call it read file bytes, and I'll build on top of it, which will be read file line. It will again take in path string in the list. Sorry, it will return a string list of strings. So in here, I'll simply call file bytes error. Uh, not error because that will be handled by that. So read file bytes with the path, and for uh, line in range strings dot split. So we take in the source, which is file bytes. Actually, let's do bytes dot split, and yeah, that will error out because this is a string and it expects a byte. How do we do it? Yeah, that's done. And then we create a line which will be a list of strings, and lines will append lines, append each individual line. So use of package. Yeah, we need to convert that into string. So that is that, and return the line. Okay, that's it, I guess. So here, what we will do is we want lines, so we'll use read file line, and we'll specify the path, which is input slash uh, sample.txt. So let's check that out. Oh yeah, this is what will bother it. Input. Okay. Okay. It didn't return any value here, which is quite surprising. Uh, did we actually load in the file bytes? or did we mess up? Well, it seems the issue is here. Line bytes dot split 5 bytes into list of bytes. So uh, let's try out with the strings method. That works, but this is not. That is weird. Uh, why is that? So it takes in a list of bytes, right? Really? Separator. Okay, I'm not really be certain here what is the issue here. So you can see the int value for this is 10. So this is 10. Um, it's quite weird. So if I say it to split it on, let's say, 4, that also doesn't work. That's quite random. Why do this way? What is the issue? Like I know how to solve this, but I want to fix this. Like why this doesn't work? This works. Split. Was that the issue? Okay, that is working because it was we are indexing. We are using uh, the index here, not the actual value. Okay, that was a small issue. Okay, so now we have this. We now need to split those individual lines. So I'll create function part one, which will take in a so lines, which will be a list of strings, and we want to return two list of strings. So this will be the output structure. So what we want to do is we want to maintain two strings. So line, not line, list one will be an empty string, empty list of strings. So list two will be a slice of string as the same, and then for each line, for each line in range line, we will okay, I also need to do it this way. So for each line we have here, we will want to separate it out. So element, what are these? These are numbers, right? So num1 will be line dot split on spaces. So this will be numbers, and then list one dot append the numbers of 0, and list 2 append numbers 1, and return list 1 and list 2. Okay, so once we have lines, we will call list 1, list 2, count 1, call list 1, list 2. Uh, okay, There are, is it tab? Okay, it's a tab. So just want to know. Wait, how is, what is that really? So it is one, let me check that out because that is looking so creepy. Uh, there are three spaces. Okay, it's not a tab. It has three spaces, so it should be the first element itself. Okay, finally we have that. And what we're going to do here is, um, let's not call it card one, we'll call it split number. So we'll call it split list. Once we have those lists, we can use the sort package to sort a list of integers as list one. Okay, it's a list of strings. Okay, we also want to convert it into a list of integers here right away, so we won't want to do it again. So integer here, and we'll convert number num1 as strcon dot, I think it's atoi. Okay, converting to integer. So we'll pass in the number of 0 if error is not there, log dot total error. Similarly, we'll do this for number 2. Okay, so now we have sorted those things. We just need to iterate. We just need to have total score as 0, and for number uh, for I in range len of list 1. Total score will basically list 1 of I minus list 2 of I. I think we need to do it absolute, some absolute difference. So if math has, I think, the absolute, okay, I think Golang has int absolute, right? It should have that. I think in the latest edition we have added it. They had added it. Maybe- Really? Golang doesn't have absolute values for integers. That's quite it's quite a task. Uh, oh, so float 64 list 2, and now we also need to convert this into an integer. Okay, that is done. I'll take my input. That's quite nice. So let's paste that in. So that was part one, and let's move into part two. Your analysis also confirmed that what everyone feared. The two lists of location IDs are indeed very different, or are they? The students can't agree on which group made the mistakes or how to read most of the chief's handwriting, but in the promotion there noticed an interesting detail. A lot of the location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. This time you'll need to figure out exactly how often each number from the left list appears in the right list. Okay, calculate the total similarity score by adding up each number in the left list after multiplying it by the number of times it appears in the right list. Here are sample example lists again. For this example list, here is the process of finding the similarity score. So similarity score. The first number in the left list is 3. It appears in the right list 3 times. Okay, so similarity score increases by 3 times 3, which is 9. So the second number in the left list is 4. It appears in the right list once. So similarity score is 4 times 1, which is 4. Okay, so we take uh, a, a set of all the numbers in the first list and create a dictionary of that integer with a counter for the second list. So what we will have is, instead of two lists, we just have one single dictionary, or a map, you can say, that will map an integer on the left to the count of that integer in the left in the right. So that is pretty simple, I would say. It's not uh, difficult to me. Let's see how it goes. So I don't know if I want to do this again, because I can just, instead of creating two lists, I just want to, okay, we would need this, because we want to have that map in the, yeah, because those are two different lists. We don't want to mess them up. So yeah, we'll create another function called uh, create map or create symbol map or list map. That is such a bad name. Uh, let's create number map. Sounds good. So we'll again take in two two lists, which is the left and the right, and we want to return basically a map of integer and integer. So let's say we have two numbers. We want to iterate over all the numbers in the first list. So this will be list 1, the list 2. So for num1, uh, num1 in range list 1. So here we have the number, and now we want to see how many times it has been repeated in the first number in the first list. So we could be smart about it. We could uh, already compute that list, or yeah, we could do this by, yeah, let's do that. That would be much more efficient. Instead of returning only list and list here, we would return uh, list 1 count as a map of integer and integer. So I'll make this. So make is basically a function that creates and initializes the maps, because maps are null by default. So we don't run into nil pointer issues while accessing a few key value pairs. So we'll create those, and once we have the num1 and num2, we'll say list 1 counts of num1 plus 1, and list 2 counts of num2. We don't need the first list, but I'm still creating it because that looks a little neater. So list 1 counts, and list 2 counts. So we are returning map of integers and integers. Okay, we'll have map 1, map 2. Let's get back to the sample here. So you can see here we are we are able to get what we wanted. So we got 3 is repeating 3 times, 4 as 1, 5 as, yeah, we don't care about 5. Uh, 2 doesn't appear in this, so that becomes 0. 1 also doesn't appear in this, so that becomes 0 as well. That is so fine, so far so good. So here, uh, instead of list 1 and list 2, I'll only pass list 1 and map 2, right? Because I just want what is in the first list and what is the count of the numbers for each element in list 2. So for num1 in the first list, I want to basically not sort. So we have the number, and I want to check if that number is existing in the second list, will be which we can find via map 2. So if map 2 of num1 is equal to 0, then uh, let's so we will return a list of integers and the integer as well. So score list and score is equal to 0. So score list will be appended to the score list with the value of num1 times, or because it's 0, it will be 0. So the second case, which is if it's not 0, will append num1 times uh, map2 of num1. Or I think we can do that directly. Score plus equals, so I'll take the score and append it here. This is a new variable, and similarity score similarly will update here. Score. So oh yeah, this is not required. I don't need the similarity index. I just want the similarity score, which will be fetched from what is that numbers, create number map. Yeah, and we pass in the list 1 and map 2, and simply print the similarity score. Map 1, yeah, that is not used. 31, was it 31? Yeah, it is 31. So that is working fine. Maybe I could try that and put, sorry, part 1. Oh, why did I name it part 1? That should be prod. prawn.txt, guys. So this is the second number. Hopefully we didn't screw up. So that is it. Um, that's the second star. That day one is easy. That's not a big deal. Uh, so yeah, the day one is completed. So what we did, let me recap what I did here. So we are given two, uh, actually it's not a list, but we have to construct that list, right? That is also a part of pre-processing. So we basically have a string. We have splitted them on lines. So once we have those lines, we split the list. How we do that is we take all the lines, and for each line we split them with the three spaces that are provided here. It was a bit confusing because they didn't specify it anywhere. It was not actually a tab as well. So that is that. We split that individual line with the three spaces, and uh, we convert that string into number, and then we append it to one to the first part of the list. So we split them on two lists, right? So let's take the example here. It is three. It is so here the line starts three space four. So once we split it based on the three spaces, the first element, so we will return a list of 3, 4. And what we do is we grab the first element as a list 1 and the second element as 4 in the list 2. Okay, and similarly, so yeah, that is the construction of the list, right? We get list 1 and list 2 by appending the number 1 and number 2 respectively. And this was added in the second part, and not the first part. So the first part was pretty similar, right? Was pretty straightforward. We just grab the two lists, and yeah, we just range over the list. We first sort them, so we need to have this. We needed to have the smallest numbers and the largest smallest to smallest mapping. So we sort both the lists and iterate over both of them and grab the absolute difference because that's what was asked, right? Figure out how apart these are numbers. We need to add up all those decisions. So yeah, that is pair of the smallest number in the left with the smallest number in the right list, and second number is left number with the yeah, so on. So we calculate the distance, which is the absolute difference of the two numbers, and yeah, we append that, we get the total score. So that was the part one, and for part two, what we did is we wanted to have a similarity score, but this was like how often number from the left list appears in the second list. So we uh, kind of map uh, the element with the count of the number of occurrences of that element, and that is the similarity score for that number. So we do that for all the numbers in this left list and add them up to get the similarity score. So that's how we do it in Golang. That was pretty easy, right? It took 20 minutes. That could be having faster, but yeah, I'm not up to speed. I'm just trying to solve problems and improve my problem solving skills. So that was that. I'll do the approach once more because I will take a record of this uh, thing. So let me clean up this a little bit. So split list, right? So what I wanted to do is we just created this list, right? I just want one of the parts to only have the solution that the part one has. I don't want part two to be added up here. So yeah, we'll just deal with that. So let me also create separate functions for part one. So here as well, we wanted to return a list of integers. We'll do this, or no, we don't want to do that. We will do list one, list two, map one will never be used. Map two with split lines and map with the line, and yeah, that is it. We never use this two in the. Okay, that is quite interesting. So part two will be part two with the line and get the. Okay, why is it printing that? Do we have a print function somewhere? Yeah, yeah. Okay, that is it. I think I am ready to explain the part one and part two. So, hello everyone, this is Advent of Code Day 1, and I want to show how we can solve this in Golang. So, Let's read the first part, which we are presented with uh, two lists here. And what we want to do is we want to grab the smallest element in the first list and the smallest element in the second list and kind of create a so get the absolute distance of those two lists and then add those distances for each of the lines, and that will be the score for the part one. So if I can explain it here, let me explain that. It will be better if I explain it in next Calvin draw. So here we have three, four different of lists, and what we want to do is we want to convert, we want to sort this out. So instead of this, we want one three, sorry, not one three. So here we'll have one. Hopefully that is getting printed. So then if we sort them out, so it will be 1, 2, 3, 3, 3 and 4, correct? And the second list, it will be 3, 3, 3, and 4, 5 and 9. So if you take out the differences, like the absolute difference of these two numbers, of the two, like this will be a separate list and this will be a separate list. So if we take out the differences, that will be 2. So 1 minus 3 is 2. Like absolute difference of 1 minus 3 is 2. So that will be 2 for the first element. Then 1, 1. So 2 minus 3 is 1. 3 minus 3 will be 0. 3 minus 4, the absolute difference is 1. 3 minus 5, the absolute difference is 2. 4 minus 9, the absolute difference is 5. So if we add all of the numbers in this list, we'll get 2 plus 1, 3, 4, 5, 6, 6 plus 5, it is 11. And that is what is expected in this first part. That is how the approach is for the part one. So in Golang, what we do is we first read the file. So I have stored it. So let me take the example of sample. So I've stored this file in here. So this is the input file. So we take the input path of that file and we read files from the bytes. So this is another function that I wrote, which will be we'll just read the file bytes and using the os.read file, which will return the slices of bytes. So that is the function for this. And what we want to do here is we want to split the bytes on the new line character. So we will have line by line slices of that string. It will be bytes. So we need to cast that in that line into string. So we do bytes dot split. We take the slices of bytes, this is the entire file byte, and use the separator as new line character. And yeah, if that line is not empty, which is h space for the last line, and we'll append that line converted into string into the lines, which is initialized as empty lists of strings. So that will give us all the list, give us all the lines individually. So if I try to print this line and I'll just comment out the part 2 here for a moment. So you can see this is what it has given us. It is a list of strings, and so this will be a single list. And if Okay, that's not a little clear here. Let me do for line in range lines. So you can see the first line is 3 and 4. Line 1 is 4 and 3, 2, 5, 1, 3, 9, so on. So that is a list of strings that we have used, and thereafter what we do is once we have the line, we call this pattern function which takes in all the lines, list of lines, and we split the list. So we take one list and we give out two lists which are converted into integers as well. So what we want to do here is, so we have lines, and this is what a line looks like. So it is 3 followed by 3 spaces and the next number. So what we want to have is, we want to have list with 3 comma 4. So how we do it is, so we take the first line, this is the first line, and we split that line into 3 spaces. So in this numbers we will have 3 comma 4 as the numbers, and this will be list, this will be strings, right? And we need to convert them into integers. So we convert each of the numbers into integers and append them into the respective list. So first number will be into the first list and the second number will be in the second list. So that's how we get list 1 and list 2. So that is the part 1 here. And yeah, once we have two lists, we basically sort that list of integers for both the lists, and we basically grab those individual lists. So I'm just iterating over one of the lists and I index that element. This is match.absolute, which takes the absolute differences of two numbers, and there's no function for Golang to uh, do the absolute sum on integers. So I have to convert the integer. This will be an integer, right? So integer into float and then back to integer. So this is one edge case here. So list 1 of I minus list 2 of I. So this two list will have the same number of elements, so that's why I can use it with any of the lists, and that won't give me any index error. So I'm using I as a reference from the first list and grabbing both the lists and getting the absolute difference of both the numbers. Once we have that, we append it to the total score, which is initialized to 0, and that's how we get the total score for the part 1. Once we have part 1, so you can see this and it reads 11, which is the expected result for part 11, and I did my input and that is working fine. So let's move into part 2, which is similar. So uh, part 2, I again take the lines, which is a list of strings, that is line by line uh, strings. But here I do a little differently, because I just don't want two lists. I want a list and a map of integers. So split lists and map. What it does is, it takes in all the lines and splits them um, as usual. But instead of creating two lists, I am creating two lists here. But down the line, I don't use the second list and the first map. I just use the first list and the second map. So what this map is, right? So I iterate over all the lines, and this is the line. So the line will have this is a similar flow here. It will have 3 followed by 3 spaces and 4. So that's how we split that line into numbers. So this will have numbers into string representation of 3 comma 4, and that's how we grab the numbers of the first index and convert them into integer. So and then append that number for the list one here. So for map, what we so let's first look into the part two actual question instead of jumping right into the solution. So part two, what it expects is it takes so we have the same input, but what we want to do now is we want to grab the number in the left list, the first list, and multiply that with the number of times that number has appeared in the second list. So in this case, let's take for 3, and 3 has appeared 1, 2, 3 times. So that will be 3 times 3. Okay, let's explain it here. So so now here we don't want sorting to be done because we just want the numbers in this list. So this is 3. Uh, we now want to count how many numbers of times 3 has appeared in the list. So we'll say 3 has appeared 1, 2, and 3, right? So we'll call it 3. We need to multiply those two numbers and we will get 9. Similarly, the next number in the first list is 4. It appears only once in the second list, so it will be 1, which will be 4. And the next number is 2. It has not appeared in the second list, so it is 0, which will be the 0. And the fourth number is 1, which again has not appeared in the second list, so it will be 0. And the fifth and the sixth numbers are we have already computed. It is 9. 3 again has appeared in 3 times, so 9 as well. So 9 plus 9 plus 9 plus 4, which is 31. So that is the final score for this. So here what we can improve here is instead of iterating over the list, we can create a set. We don't have sets in Golang, but we can create a list which doesn't have duplicate elements, but that is a little expensive to do here. We'll stick with the normal approach. So in let's go into the code. So for part two, what we want to do is we have similar approach here as well. So we'll take in the list of integers, a list of strings which is separated by new lines. So we'll grab so the lines will have so lines is a list of strings which is strings of each individual line, and we have created a separate function called split list and map. So it takes in a list of strings lines, and what it gives out is two lists of integers and two maps of integers with integers. So we iterate over all the lines and we do the splitting for that line on the three spaces, and after we split them in three spaces we get the first number and the second number. We convert those numbers into integers and append them into the respective list 1 and list 2. The only difference I have here is I create the two maps, list 1 counts and list 2 counts, which will be a map of integers and integers. What it will store is the number on the left, so the number so one will be the first, so the left side list, and the value for that key will be the number of times that has appeared. So num1, we are not using this, we can skip this, but list2, that's what we want here, right? So we want to have how many times 4 has appeared in in this list, which is 0, um, which is 1. So we'll append num2 plus 1 and similar. So yeah, that's how we get the map of second second list, and we will have the key as the number itself and the value as the number of occurrences that number has in that list. So this is part 2. So we get list 1 and map of 2. So remember what we have written from this uh, function, which is two lists and two maps. The first one first list and the second as map 1 and map 2. We don't want list 2, we don't want map 1, we just want list 1 and map of 2. So in this create number map, I pass in list 1 and map 2, and what I do here is I iterate over all the numbers in the list 1 and find that number occurrences as indexing that. So this since this is a map, I can index the number 1, so number from the list 1, and get its occurrence here, because the value for this will be the occurrences for that number in that list. And yeah, we have multiplied that and we append that to the score and we get the similarity score, which is what we expected here. So we get the similarity score as 31. So yeah, that is from part 2 as well. That was day 1 from Advent of Code 2024. I guess that's it, right? Yeah, that's it. I will see you tomorrow for the